Alright, this is our presentation for the RBE3002 Lab 5 Autonomous Mapping Robot Project. I am Craig DeMello, and presenting with me is Grant McDonald and Sam King, and the instructors for RBE3002 were Taskin Padir and Sonia Chernova. So the problem we approached in the class was to navigate to specified waypoints in a dynamically changing maze while using sensors to map the environment around the robot. And then we would send the map to a graphical user interface on a computer external to the robot via serial communication. And then we use an algorithm to determine the shortest path back to the starting location once the map was constructed. Our approach to the problem involved using the wavefront or wildfire algorithm, and we used a 68 by 68 virtual grid. And for the GUI, we used an occupancy grid, which was also 68 by 68. We developed a navigation class to move from point to point, which kept track of the heading as a global variable and then would increase the X or Y depending on where the robot was trying to move to. We moved incrementally by setting goals in the path to the waypoint. So we would set a waypoint 3 spaces in front of us instead of trying to go the whole distance to the goal, and then we would map at that location and then rerun the algorithm. And we would also send the information back to the GUI at this time, and at the end of the mapping segment, we would rerun the wavefront from the endpoint to the start point to get back to the original starting location.
I'm Sam King, and I'm going to talk a little bit about what we had to do to adapt our program for use with the real robot. The real robot was fairly similar to the virtual robot, except we had several sort of real-world challenges. So what we did is we swept the sensor more often and in bigger increments. We used only the sonic sensor because the infrared returned a lot more noise. We only read sonic values from less than 30 centimeters away. Within 30 centimeters of the robot, we had fairly accurate results, but further away, a lot of noise, and it became much harder to actually predict where we were. And then with the grid cells changed because the size of the map changed. All right, so here we can see the virtual robot results. As you'd expect, we have nearly perfectly straight lines, because everything in the virtual world works exactly perfectly, no sensor noise, etc. So here we can see the real results from the real robot. We achieved reasonably good results. As you can see, fairly minimal noise. We did successfully map the environment, fairly straight lines, and this is accredited to, as I mentioned previously, only accepting values within 30 centimeters of the robot and only using the ultrasonic sensor. So in conclusion, for our results, we achieved accurate motion and goal positioning in the grid. We were able to navigate to our 5 waypoints, and we were able to plan the shortest path there and back.
I'd like to discuss some of the things we could do to make our results better. With higher quality sensors, more accurate maps could have been achieved. If our robot had more accurate odometry, we could have made for easier navigation. Our robot also could have been expanded to include probability and line mapping, and also a less noisy environment would have allowed for us to use Bluetooth wireless communications instead of using a very long tether. We'd now like to show you a video of the robot working, going from the beginning to the end of the maze and back.
As you can see, in the upper left corner of the video, we have our GUI, which is running on our laptop, and the information from the robot is being sent to the GUI via the serial cable you can see in the video. The map is getting updated every 3 grid squares the robot drives to, so that's 8 centimeters per grid square. And the reason the video is sped up is because the robot takes a pretty good amount of time to do sensor sweeps, which makes the overall process time consuming. You can see the robot is filling the map. It's only picking up values from less than 30 centimeters away, so we're getting a fairly accurate map, though we're not mapping too far in the future. And the robot is avoiding the obstacles, the walls, and going towards the waypoints, which you can see on the field, are marked with the red X's, and it continues on its path planned by the wavefront algorithm. The wavefront algorithm is run every 3 steps. When you see the sensor sweep, it sweeps the sensor, runs the wavefront, and then sends the information to the computer via the serial cable, updates the GUI, and then drives the next 3 spaces and repeats the same process.